Hello everyone, this is Nirali Patel from the IIT Institute of Engineering and Technology. In today's lecture, we are going to discuss examples on measure of statistics for continuous random variables. So let's get started. So the first example is that a continuous random variable x has the PDF defined by, that is nothing but the probability density function f of x is a plus b of x, a plus b into x, where x lies between 0 and 1. If the mean of the distribution is 1 by 3, find the value of a and b. So here the value of mean is given, that is 1 by 3, and the f of x is also given, that is a plus b into x, where x lies between 0 and 1. That is the range for the x. So mu is also given and f of x is also given. We have to find the a and b. So mu is equals to nothing but minus infinity to infinity x into f of x dx. So that is equals to minus infinity to 0 x into f of x dx plus 0 to 1 x into f of x dx plus integration from 1 to infinity x into f of x dx. Now this first term and this third term would become 0 because the x lies between 0 and 1. Okay, so the f of x is not defined for minus infinity to 0 and 1 to infinity. So 0 to 1 x into a plus bx dx, that is equals to 0 to 1 ax plus bx square dx. So a x square divided by 2 minus, plus bx cube divided by 3. Lower limit is 0 and upper limit is 1. So the a by 2 into 1 plus b by 3 into 1 is equals to 1 by 3, because the value of mu is equals to 1 by 3. So 3a plus 2b is equals to 2. So this would become equation number 1. Now we know that minus infinity to infinity f of x is equals to 1. So minus infinity to 0 f of x dx plus 0 to 1 f of x dx plus 1 to infinity f of x dx, that is equals to 1. So that this first and third term would become 0 because f of x is not defined for minus infinity to 0 and 1 to infinity. So integration from 0 to 1, f of x is a plus bx, that is equals to 1. So that is ax square divided by 2 plus ax divided by 1 plus bx square divided by 2. Lower limit is 0, upper limit is 1, and that is equals to 1. So that can be written as 2a, because x is 1, plus b is equals to 2. So this would equation number 2. So now we have two equations. This is equation 1 and this is equation 2. So the first equation is 3a plus 2b is equals to 2, and second is 2a plus b is equals to 2. So we can multiply this second equation with 2. So 3a plus 2b is equals to 2. 6 for a plus 2b is equals to 4. Now by performing 1 minus 2, so this would become cancelled. Minus a is equals to minus 2. So 8 would become the 2. So let's just put the value in either 1 or 2. So I'm putting into 2. So by substituting equation number 2, so 2 into 2, that would become 4 plus b is equal to 2. So b value is minus 2. So the value of f of x is 2 minus 2x, where x lies between 0 and 1. So we can also write f of x is equal to 2 into 1 minus x where x lies between 0 and 1. So this is the value of a and b, and after that we can write the f of x is 2 into 1 minus x, x lies between 0 and 1. Now coming to the next example, so it is given that a continuous random variable x has the distribution function. Here the distribution function is given instead of the PDF, that is the probability density function. F of x is equals to 0 when x is less than 1. K into x minus 1 is to 4 when x is greater than 1 and less than or equal to 3 and equal to 1 when x is greater than 3. First we have to determine f of x. So for the first case, f of x is nothing but d by dx f of x. So f of x would be 0 when x is less than 1, then 4k into x minus 1 is to q when x is greater than 1 and less than or equal to 3, and 0 when x is greater than 3. So this is about the f of x. Now the next thing that we have to find is k. So we know that integration from minus infinity to infinity f of x dx is equals to 1. So this can be written as minus infinity to 1 f of x dx plus 1 to 3 f of x dx plus 3 to infinity f of x dx is equals to 1. So here the f of x is 0. So 0 plus 1 to 3 4k into x minus 1 q dx plus 0 is equals to 1. So here we have to take the integration. So 4k would become the common, and the integration for x minus 1 q. So integration from 1 to 3 x minus 1 q dx is equals to 1. Now this x minus 1 q can taken as t q. So x minus 1 is equals to t. So for x is equals to 1, t would become 0 if x equal to 1. And for x equal to 3, t would become 2. So we can define this integration as 4k integration from 0 to 2 t cube and dx. So for the dx is equal to dt. So that would become the dt equal to 1. So 4k t raised to 4 upon 4, 0 to 2 is equal to 1. So 4k into 4 is equal to 1. So the value of k would become 1 by 16. Now the third case is for the mean. So mu is equals to minus infinity to infinity x into f of x dx. So we can write mu is equals to minus infinity to 1 x into f of x dx plus 1 to 3 x into f of x dx plus 3 to infinity x into f of x dx, that is equal to 0 plus 1 to 3 x into f of x, that is 4k into x minus 1 cube dx plus 0. So that is equals to integration from 1 to 3 4k. So the value of k is equal to 1 by 16. So that is equals to 1 by 4. That would become the common x into x minus 1 whole cube dx. Now taking x minus 1 as t, as we have done in the previous case, x would become t plus 1. So that is equals to 1 by 4 integration t plus 1 and t cube dt. Now for x is equals to 1, t would become 2 and t would become 0, and for x is equals to 3, t would become 2. So the lower limit is 0 and upper limit is 2. So 1 by 4 integration from 0 to 2 t raised to 4 plus t cube dt. So that is equals to 1 by 4 and t raised to 5 upon 5 plus t raised to 4 upon 4 Lower limit is 0 and upper limit is 0. That is equals to 1 by 4, 2 raised to 5 upon 5 plus 2 raised to 4 upon 4. So the final answer of mu is equal to 2.6. Now coming to the next example. So if the density function of random variable x is given by f of x is equal to kx into 1 minus x, where x lies between 0 and 1, determine the arithmetic mean, harmonic mean, median, mode, standard deviation, mean deviation about the mean. So let's first find out the value of k in order to determine the AM, HM, median, mode, standard deviation, and the mean deviation. So for finding out the k, we have to take integration from minus infinity to infinity f of x dx is equal to 1. So that is minus infinity to 0 f of x dx plus 0 to 1 f of x dx plus integration from 1 to infinity f of x dx equal to 1. This would become 0 because f of x is not defined from minus infinity to 0. Integration from 0 to 1, k into x into 1 minus x dx plus this would also become 0 because x is also not defined between 1 and infinity is equal to 1. So that implies 0 to 1, k it would become common because that is the constant, x minus x squared dx is equal to 1. And that implies k into x squared divided by 2 minus x cubed divided by 3, 0 to 1 is equal to 1. K into 1 by 2 minus 1 by 3 is equal to 1. So the value of k, 1 by 6 is equal to 1. So the value of k would become the 6. So we can write f of x as 6 into x into 1 minus x, where x lies between 0 and 1. Now for the arithmetic mean, that is nothing but mean. So mu is equal to minus infinity to infinity f of x dx, x into f of x dx. So that is minus infinity to 0, x into f of x dx plus 0 to 1, x into f of x dx plus integration from 1 to infinity, x into f of x dx. So this would become 0. Then integration from 0 to 1, x into 6 into x into 1 minus x dx plus 0. So 6 would become common. Integration from 0 to 1, x squared into 1 minus x dx. That is equals to 6 into integration from 0 to 1, x squared minus x cubed dx. That is equals to 6 into x cubed divided by 3 minus x raised to 4 divided by 4. Lower limit is 0, upper limit is equals to 1. 6 into 1 by 3 minus 1 by 4, and that is equals to 6 divided by 12. The answer is 1 by 2 for the mean. Now the next thing that we have to find is HM. So 1 by h is integration from minus infinity to infinity 1 upon x f of x dx. So 1 by h is equals to minus infinity to 0, 1 by x f of x dx plus 0 to 1, integration from 0 to 1, 1 by x into f of x dx plus integration from 1 to infinity, 1 by x f of x dx. So 0 plus integration from 0 to 1, 1 by x. The value of f of x is 6 into x into 1 minus x dx plus 0. X cancel. Integration from 0 to 1, 6 into 1 minus x dx. So that is 6 integration from 0 to 1, 1 minus x dx. That is equals to 6 into x minus x squared divided by 2, 0. Lower limit and 1 is the upper limit. So 6 into 1 minus 1 by 2, that is 3. So 1 by h is equals to 3. So we can say that h is equals to 1 by 3. Now the next is the median. For median, integration from a to m, f of x dx is equals to 1 by 2. A is 0 and f of x, that is 6 into x into 1 minus x dx is equals to 1 by 2. So 6 would become common. Integration from 0 to m x minus x square dx is equals to 1 by 2. So that is nothing but x square divided by 2 minus x cube divided by 3. Lower limit is 0, upper limit is m is equals to 1 by 2. So the answer for that is equals to 6 into m square divided by 2 minus m cube divided by 3 is equals to 1 by 2. So therefore 6 into 3m square minus 2m cube upon 6 is equals to 1 by 2. 6 would become cancel. 2m cube minus 3m square minus plus 1 by 2 is equals to 0. So that is 4m cube minus 6m square plus 1 is equals to 0. Now the one root for this is 1 by 2. So m minus 1 by 2 upon into m minus 1 by 2, and the one more is m minus 1 by 2. So here the 4m square, so 4m cube minus 2m square minus 4m square. So over here minus 4m plus 2m minus 2m. So minus 2 plus 1 will become 0. So the equation is 1 is m is equal to 1 by 2, or 4m square minus 4m minus 2 is equals to 0. So 2m square minus 2m minus 1 is equals to 0. So this is A, this is B, and this is C. So the root for the m is equals to minus b plus or minus under root of b square minus 4ac upon 2a. So 2 plus or minus 4 minus 4 into 2 into minus 1 upon 4. So 2 plus or minus 4 minus plus 8 divided by 4. So that is 2 plus or minus 2 under root of 3 divided by 4. So the m would become 1 by 2 plus or minus root 3 by 2. So here the value of m is equals to 1 by 2 is lies between 0 and 1. The value of median is 1 by 2. Now the next thing that we have to find is mode. So to find out the mode, the value of x for which f of x would become the maximum, that is the value for the mode. So f of x is 6 into x into 1 minus x, that is nothing but 6x minus x square, and where x lies between 0 and 1. So f dash x is equal to 0. So that is 6 into 1 minus 2x is equal to 0. So the value of x would become the 1 by 2. Now f double dash x. So the value of f double dash x is 6 into minus 2, that is minus 12. So f dash x is minus 12. So at x is equals to 1 by 2, the value of f double dash x, that is minus 12, is less than 0. So the value of mode is equals to 1 by 2. Now the next thing that we have to find is standard deviation. So we have already the value of mean. So now let's just find out minus infinity, that is e of x square, minus infinity to infinity x square f of x dx. So that is minus infinity to 0 x square f of x dx plus 0 integration from 0 to 1 x square into f of x dx plus integration from 1 to infinity x square into f of x dx. So this would become 0, then integration from 0 to 1 x square into 6 into x minus x square dx plus 0. So that is integration from 0 to 1, 6 would become common. X cube minus x raised to 4 dx. That is equals to 6 into x raised to 4 divided by 4 minus x raised to 5 divided by 5. Lower limit is 0, upper limit is 1. So 6 into 1 by 4 minus 1 by 5. So that is 6 divided by 20. So the answer for this is 3 divided by 10. Now, in order to find the standard deviation, SD is equals to square root of sigma square, and that is denoted by sigma as well. So sigma square is equals to E of x square minus E of x. So E of x square is 3 by 10, and the value of mean is 1 by 2. So this is E of x whole square. So 1 by 2 whole square. So 3 by 10 minus 1 by 4, which is equals to 12 minus 10 divided by 40. So the answer is 2 by 40, which is equals to 1 by 20. So this is nothing but square root of 1 by 20. So that is equals to 1 by 2 under square root of 5. So this is about the standard deviation. Now the next thing that we have to find is mean deviation. So mean deviation is equals to minus infinity to infinity x minus mu f of x dx. So that is minus infinity to 0 x minus mu f of x dx plus 0 to 1 x minus mu f of x dx plus 1 to infinity x minus mu f of x dx. So this is equals to integration from 0 to 1 x minus mu f of x dx. So that is equals to 0 to 1 by 2 mu minus x f of x dx plus 1 by 2 to 1 x minus mu f of x dx. So 0 to 1 by 2 mu minus x, so that is value of mu is 1 by 2 minus x into 6. Value of f of x is 6 into x minus x square. So x minus x square dx plus 1 by 2 to 1 x minus 1 by 2 into 6 x minus x square dx. That is equal to 1 integration from 0 to 1 by 2, then 1 by 2 minus x into 6x minus 6x square dx plus 1 by 2 to 1 x minus 1 by 2 6x minus 6x square dx. So the integration from 0 to 1 by 2, 3x minus 3x square minus 6x square plus 6x cube dx plus integration from 1 by 2 1, 6x square minus 6x cube minus 3x plus 3x square dx. That is equals to integration from 0 to 1 by 2, 3x minus 9x square plus 6x cube dx plus integration from 1 by 2 1, 6x square plus 3x square, so that is 9x square minus 6x cube minus 3x dx. So this is 3x minus 3x square divided by 2 minus 9x cube divided by 3 plus 6x raised to 4 upon 4. Lower limit is 0, upper limit is 1 by 2 plus 9x cube divided by 3 minus 6x raised to 4 upon 4 minus 3x square divided by 2. Lower limit is 1 by 2 and the upper limit is 1. So this would become equal to 3 by 8 minus 3 by 8 plus 3 by 32 plus 3 minus 3 by 2 minus 3 by 2 minus 3 by 8 minus 3 by 32 minus 3 by 8. So these 3 by 8, 3 by 8 cancel, 3 by 8, 3 by 8 cancel. Now 3 by 32 plus 3 minus 3 plus 3 by 32. So that is nothing but 3 by 16. So this is all about today's lecture. In next lecture, we will start with the new topic. Till then, keep exploring and thank you.